So as I was saying, the lowest possible temperature called absolute zero is about, that means about negative 460 degrees Fahrenheit. So I want you to write that down so you know that, okay? You'll need that for another activity down the road, all right? So it's the lowest possible temperature. That means that particles have no moving energy. They literally stop, or they stop vibrating. They stop moving and they stop vibrating, okay? All right, let's do the next three real quick. And before I do that, let me get a Post-it note because I want to do this one by one, and I don't want to copy the others real quick. And I'm going to read this to you. So let's talk about conduction, convection, and radiation. So first of all, conduction is the transfer of energy from one substance to another through direct contact. The transfer of energy from one substance to another through direct contact. So in other words, an example of conduction would be like this. An example would be like touching a hot stove. Touching a hot stove, that's a great example of conduction. Meaning the stove that's hot is going to transfer the energy, its warmer energy, or its higher kinetic energy into your hand. Because remember I told you that atoms don't like to be hot, they like to be cool, they like to be calm, they like to be chill. And if they can get rid of some of their extra energy, they'll do that. So the stove will transfer its energy into your hand, causing it to cool down and your hand to burn up, to heat up, yes. That's called conduction. Convection works a little different. So convection is the transfer of energy when warm particles rise. The transfer of energy when warm particles rise and cooler particles sink. And a great example of convection is an oven. An oven. I'm going to assume that the if you're using an electric oven or electric stove, that the burner, or excuse me, that the heat source is on the bottom. So what happens is the heat source will heat up the atoms closest to it, yes, and as they do that, you'll understand a little later that atoms, like when they heat up, they like to expand, they like to spread out, yeah, because they're so hot. And when they do that, they go to the top of the oven, yes? And when they get to the top of the oven, they're farther away from the heat source, so then what they do is they start to condense or come together and cool down. And they do this in a cycle, so they'll go down to the bottom of the oven, heat up, and then lift to the top. And then cool down and go to the bottom, and then heat up and rise to the top. And so that circulation, like this, and I want you to draw that, is how a convection oven works. That's how it heats your food very, very evenly. Okay? That's convection. So radiation and conduction are quote unquote similar in this way. So radiation is the transfer of energy also through waves. Really electromagnetic waves, but we don't need to use that right now, that term right now. It's the transfer of energy through waves, and this is done with no direct contact. No direct contact. So a great example of the transfer of thermal energy through waves is the sun. Like, we don't touch the sun in order to feel its heat. Yeah, what it does is sends down waves, or electromagnetic waves, yeah, and it heats up the source. But the sun itself does not physically touch us, yeah? That would be disastrous. All right, so when you're done with all of these, you're going to bring this up to me and show me, and you are finished. Thanks.